All right, we're gonna get started now. Earlier, you heard an announcement about being on black team, especially if you're a freshman. And I know a lot of freshmen. You have no idea what a black team is, especially if you didn't get a chance to do IRSEC. This is your chance to learn what black teaming is, why it's super cool, and why you should do it, and why you should apply it. And everyone in this room should fill out that ISPS black teaming form because it's super cool, really good experience. You'll figure out why. We have a lot of slides about it. So first off, who in the room doesn't know me? I know I haven't been around much. You can't say that. You can't say that. And half these people are liars. Okay. It's okay. So my name is Bradley Harker. Yeah, I was just gonna do names first. I'm Bradley Harker. Most people call me Brad. So if there's anything during the presentation, if I'm doing a terrible job, you can just shout, Brad, you suck, or something like that.
I'm Anthony. Yeah.
You probably know Anthony.
Yep. And I'm Max.
Can they see you in the thing?
I don't know.
Max Cucho.
Oh. Okay. Yeah. Starting off. Yep. I'm Max. I'm a BSMS math minor. I'm graduating this semester. I think, if the count's right, this is presentation 31. So we're about to break records again. As previous vice president and tech lead, I do a ton of security engineering, ops, pen testing type stuff. I love Golang. It's my entire personality at this point. Currently, I work full time at Akamai, and I will be incoming full time at Dad Dog February. Yippee.
Like I said earlier, I'm Bradley or Brad.
I'm from Richmond, Virginia, and previously I was solely a dumpling enjoyer, but now we have Tony here, a new addition, both as featured in #CAT. If you saw last night, I posted it. I said this would be relevant tomorrow. It's now relevant. I'm a 5th-year computing security BSMS student. I'm also a part of the Cybercore Scholarship for Service, or SFS program, so I know a lot of people have questions about that. If you have questions, it's a good program if you want free tuition. I was also the RITSEC president last year, so if you're a freshman this year and you don't know who I am, that's who I am. I'm just old and retired, and that's why I'm not around much. Also, Golang is the best lang, but it's because I'm too dumb to learn Rust. So for all you who know Rust, you're probably way smarter than me. I also love pen testing. I got super into embedded systems this summer. Joan knows a little bit about that. And I'm also super into DevSecOps, so networking, infrastructure automation, cloud security, that kind of stuff. Speaking of cloud security, shameless plug to my presentation last year. I had a 2-part presentation series on cloud security. Go watch it on YouTube.
I'm Anthony Ioppolo, the president. Hooray! Year 4th-ish cybersecurity, and I'm from Scranton. Yeah, that's Scranton. I was at IBM this summer. I took the RITSEC to MITRE pipeline. Very good enjoyer. They both said Golang, so I'm just going to say Golang. The Bosnian Goku socks in the club room, those are mine. I got them from Bosnia and Sarajevo. Big fan. Wizard on the harmonica also. You can ask me for a lowrider or half of Happy Birthday, and I can play it. You can ask me about the terminal. You know this.
Everyone has to ask me about the terminal.
That's true. I'll tell you.
Learn about the terminal.
Tell you real good. So, competition types. So we're black teaming, right? Depends what kind of competition you're going to be walking into. And if you were at IRSEC, it was a red versus blue competition. So you're going to get a semi-realistic kind of look at what an enterprise environment would look like. And every single team is going to get an identical copy of this environment. So you're going to have different operating systems, different services, and all these different things, and you're going to be fighting against the bad guys. So there's going to be a lot of blue teamers, and they're on defense. So we had 15 teams for IRSEC, and then we had a single red team, and they were in the cyber range, and it was going back and forth. So a lot of blue teamers, one red team. And examples of this are IRSEC, ISTS, which will be running in the spring, any UB lockdowns, and CCDC are all examples of the red versus blue style of competition.
Feel free to interject if you have questions. This is going to be a somewhat high-level presentation. There's also going to be some technical stuff, but I know you guys are going to have questions. Please don't be afraid to just raise your hand. We'll answer anything and everything. All right?
Heckling enabled, if it's nice. The next style of competition is capture the flags. So this is like the capture the flag. That was the other thing. These are Jeopardy style competitions. So if you've seen Jeopardy, you know that you're gonna have these goofy little topics, and then as you progress, questions and challenges are gonna get harder and harder as you go on. And you're gonna get things like break this website. There's gonna be cryptography challenges, like forensics, and then even just stalking me, which Zach is a fan of, for those types of challenges. And there's all these different categories. You compete against the other people. You get points. The more points you get, the more you win. And examples of this are the RITSEC CTF, which will also be running in the spring, the WESA CTF, which ran this fall, and Seesaw. And then lastly is King of the Hill. So King of the Hill is kind of like a pen testing specific competition. You're going to get thrown into an unknown network topology, and there's going to be a ton of intentionally vulnerable machines in there. So you have to get in, get on those machines as fast as you can, try to patch as much stuff as you can, as fast as you find them too. Yeah, you have to find. First off, you have to find them before you can even do anything. Then you got to find out how they're broken. Then you got to fix them. Then you got to make sure you can get back onto them in case you lose them. And it's a whole thing. You're just fighting to be at the top of the hill, or the king of the hill, if you will. And an example of this is during ICS, we also have a King of the Hill simultaneously with the red versus blue competition, and also the capture the flag, and also the game. But that's a really good example if you're interested in that.
I think I forgot to put this in there, but I think also Try Hack Me runs King of the Hill competition. So if you're interested in like giving this a try on, I don't know, a random time of the year, not just ISTS, I think they do like, I don't know if it's annual or multiple times a year, but Try Hack Me, super great website. They run King of the Hill competition. So if you want to put your skills to the test, definitely go compete.
And this is going to be similar to like a hack the box, except you're hacking the box against other people as well. So there are some roles in setting up these competitions, and these are going to be the technical ones. So we have different like categorizations. We have the infrastructure team. They're going to be managing all like the infrastructure side of things. Surprise, surprise. The operating system teams are going to be doing like Windows, Linux, anything goofy that we put in there as well. Scoring team is going to be looking at how people are actually getting points for what they're doing, which is pretty much the entire competition. And then there's like the inject side of things, which is a less technical role, but you're responsible for injects, which are like surprise challenges that are thrown in during the competition. So the operating system teams, you're going to be writing Ansible to deploy all these services, and we're going to have a fantastic Ansible demonstration at the end of this, so you'll know how it's going. You're going to be using Packer to generate base images that we use for these competitions, so you can just say, you know what, give me like 17 Hannah Montana Linux boxes, and it'll just go through and deploy all of those. And there's going to be unique scoreable services on each of these hosts that need to be deployed with Ansible as well. So there's like the ICMP checks, SSH checks, all these different things that you have to consider while you're on the operating systems team. Breaking it down a little bit more, it's typically just Windows and Linux unless we have something goofy thrown in, but you're going to have to be thinking about different versions on Windows, like 10, 8, 95. Don't research Windows 9. Worst mistake of my life. You're going to have to be considering, oh, do I want to use any servers, like 2022, 2016? And then you're also going to have to be fighting Windows itself. So there's just general Windows tomfoolery. I'm sure Kenny would be happy to talk about all that. Defender, Active Directory, all these little things that you have to consider when making an accurate enterprise-level Windows environment. And then some good services that you're going to want to be scoring are Active Directory, SMB, WinRM, IIS, like websites, MS SQL, and ICMP checks. Linux, on the other hand, you're going to be worrying about distributions like Debian, Ubuntu, FreeBSD, Hannah Montana Linux, Debian, Debian,
Justin Bieber.
Like Justin Bieber, Debian. I hate that. I hate that a lot. And then you're also going to have to consider different things as well, like package installs, how those are going to work, how you're going to put in users, what kind of dependencies you're going to have, how are your services that you're deploying going to be persistent. And some services you're going to consider on these is like SSH, FTP, web, MySQL, PIN, ICMP. All these different little like services you have to keep running on each operating system. And then the infrastructure team. So these are going to be the people that kind of build the back end of the competition, and they're going to be using Terraform to manage this, which we also have a fantastic Terraform demonstration. Who knew? And you're going to be building all these different hosts, and you're going to be doing this with the Terraform code. So during the competition, you run the Terraform code, everything breaks, you can go back and say, okay, let me change this one thing, run the entire thing again. You change one box on a system of 220 machines, it'll just rerun the same exact thing, so you can just keep deploying the infrastructure over and over again. So you're going to be managing how everyone accesses these competitions, and managing like kind of the hypervisor for the stack that we put all of our computing power for these competitions on. And then this could be either physical or virtual networking, so you kind of got to be on your toes for infrastructure. Then scoring. Big part of the competition is how you're actually getting these points for these scored services. So some of the ones that we've seen in the past are scoring engine or score stack. Some new ones, Max would know, ComScore, which are shameless plug for ComScore. Allows you to get points for your services for having them up, or uptime as it's called. You could also write custom score checks. I know I had to do this in the CBT class, but that was just in Python for like a web check. I just see if the website's running, what kind of error codes it comes back with, and things like that. And you're also in charge of scoring the final competition score. So when everyone like comes in the room, all tired at the end of the day, and sits around the little TV like kids on Christmas, that's you. You pick who's third, second, first.
Arguably one of the most important teams.
Yeah, arguably probably one of the most important teams, because that's actually how people see how they did. And injects. So injects are fake business requests that match the theme of the competition, and they will just appear at random points throughout the competition. So we like to like get into character. Part of the grading is actually, if you fit into the theme, try to have fun with it. There's going to be grading rubrics that come by. So say an example inject is, tell us about all the users you have. And do they have all their users? If not, we'll dock them points. So using these grading rubrics and distributing them for the inject team so they can grade these as well. And white team, which we'll talk more about, I think, has a role in grading these injects as well. White team is another very important part of the competition. And then the distribution of injects. So normally these could come through like email, or you could get a USB with them, you could get a Discord ping. You could chase Ross through the GCI and find him sitting in one of the rooms all alone in the dark and take a flash photo of him. Totally, there's a bunch of different ways that you could get these injects, and being able to return them to the people who grade them is an important part of the competition.
All right, so we're gonna switch around. That was probably like a lot of technical dense information. Don't worry, you don't have to understand it all. This is here as a resource. These slides will be posted as you learn over the years, and there will be more black team presentations in the future, I promise. But you can always use these as a reference for yourself. These are kind of just general guidelines, high level overview of what black teaming is about. So let's get into a little bit of the less technical roles here. So the competition architect, the big cheese, as Anthony so kindly put it. The competition architect's the person really in charge of the whole thing. So hence architect, they're actually designing and making the entire thing. But what this really means is that they act as a project manager for the entire competition. We have black team for a reason. There are people who do the technical roles that Anthony just described, and that means that this leaves time for the competition architect to do planning, project management, and making sure everything is on time. So the competition architect is going to be the person who coordinates all of the different team leads. So these are similar things like you just heard, as well as some of the more administrative teams that we'll get into. So the scoring lead, the white team lead, the OS team leads, infrastructure team leads, etc. They're going to be coordinating all of these team leads to make sure that progress is sufficient, progress is heading towards the correct deadlines. We're not going to miss any deadlines. Things are going to happen. Come day of competition, this thing's going to run. One of their primary goals, and this is something that I think we've been really pushing in the past few years, is to ensure that every single task is delegated. Now, if you're in this room and you are thinking of being a competition architect, I want you to look at me right now and pay attention, okay? This is a very, very important point. And I think it's one that if you want to be a manager in the future or anything, this is super important. You as one person cannot make the competition happen. This is the reason you have a black team. This is the reason you have a white team, etc. You need to make sure that every task that needs to happen for this competition is delegated to someone other than you. Because if you are busy doing tasks, that does not leave you open to answer everyone's questions. Because I guarantee you, you are going to get hundreds of questions a day from people, Discord pings, someone sees you in the hallway, whatever, and you're going to have to focus on coordinating all of that. So every minute, like technical and logistical task that needs to happen needs to be delegated to someone who's not you. Got that? Nod your head if you want to be a CA. I'm serious about this. This is how you be a healthy CA, okay? Healthy human being CA. All right, so this includes things like the theme. All right, you have an idea, but your job is not to go on Amazon and find decorations to fit that theme, okay? You may know, oh, I want to have some good food options. Someone else's job is to go find the food, get the quotes, and then you can just make a final decision, okay? Reservations, you need to reserve rooms and such. Not your job, okay? Finding all the teams, right? You can help be the decision maker, but you should be sure that other people are officially responsible for all these kinds of things. In the past, the CA has done way too much and has created high burnout for anyone who becomes a competition architect. And I want to make sure that changes. Got it? I need to see nodding heads. I'm telling you, audience participation, not just staring at your laptops, okay? I'm serious about this. So ideally, you are not a technical person as a CA. You are the big idea person, okay? You are the person in charge who's making all the decisions, all right? At the end of the day, if there is a decision that people can't come easily to, you're the person that makes the call. Obviously, I think Anthony put on here, less defined intervention is needed, but that would be like the apocalypse of competitions, where you need to actually touch a keyboard, log into a box, and do something, okay? That is like the worst case scenario. This competition is gonna explode if I don't do this, okay? You should never, ever be doing that. Everyone who wants to be a CA, put up your pinkies right now. I want you to promise me, and I'm gonna be disappointed if you break this promise, okay? Promise me that you will not hold a technical role as a CA. Yeah, pinky promise, pinky promise, pinky promise. See, look at that, audience participation. It's okay, I love you guys. This is why. I care about you, I want you to be healthy. I'm not trying to be mean, okay? Everyone who's an alumni who may be watching this will probably agree with a lot of what I have to say. White team lead. This is an important role. Your job is to organize volunteers for the day of. White team is the people who come in during competition. They're volunteering. They don't do anything except, I say day of, but what I mean by day of is the setup day, the competition days, and the teardown. So usually weekend though. But your job is to organize volunteers for that weekend. Get people here who can help, be people in the room. Whether it be setting up computers, whether it be decorating the room, whether it be, during competition, actually grading the injects, because, you imagine you have 15 teams, 15 injects coming in every 30 minutes. It's a lot to grade. So I know if you're a TA, you'll understand. It's a lot to grade. But yeah, so your job is to ensure that the day before, so setup day, and day of, or weekend of, logistics are actually happening. Hey, someone needs to go pick up the lunch for today. White team people, make sure it's delegated, right? All this kind of stuff. All of the logistics, day of, day before, should be under your purview as the white team lead. Your job is to literally just help keep the competition alive. The black team has probably been killing themselves for the past 3 to 4 weeks trying to make this competition happen, and your job is to make sure that it actually reaches the finish line. Blue team help, whether someone on a blue team needs help with something, whether it be communicating from between the different teams, making announcements, whatever. This is all your purview. Whether you do it, whether you make one of your volunteers do it, that's your job. And then again, arguably one of the most important roles on black team. And yes, we consider you a part of black team as the white team lead.
So lastly, I'm going to be going.
Hold it close.
Okay, there we go.
In front of your mouth.
Okay, there you go. So lastly is the miscellaneous roles. Competitions are always unique. They always have stuff, but overall they rhyme with each other. And these are those roles. So first, a lot of competitions have really great themes, and to go along with that, they include a game that's completely bespoke to it. It's like the ISTS special. Every year we come up with a unique game. We have a game lead who runs it, and exactly that. You design something funny, something interesting, something that gets people interested. For Mavs ISTS, last ISTS, we had the game lead run. It was back and forth hacking. So you would red team a person's box, or two people would sit down. They both red team a box. They put in persistence. Then you'd flip it, and you'd have to discover as much as possible based on how much persistence you have left. That's how many points it was. Something extremely interesting, unique, custom, and we have to do that every year. Figure out something new, and that's what the team as well as lead does. Store. This is
Don't worry about it. Keep going.
sorry. Store. I've done this quite a few times. You get a lot of points within a competition, and it's our way of being able to balance and make sure that you can do something interesting, funny, or whatever with this game. So you see at like ISTS that you can buy people's chairs or take their mouses away and stuff like that. And again, it's very similar to the game in that it just quells interest or makes it way more interesting, and people are able to get way more involved with it. Cough. I guess a lot of these say ISTS special, but yeah. Cough. This is something.
It's ISTS. But
Yeah, but for Koth, this is another thing unique that we have to ISTS. Normally, a Koth competition itself is a competition itself. Here, we run mini competitions. One of those being Koth. So you're going to be designing the entire Koth environment, and it's going to be something that people work on asynchronously throughout the competition. So you'll be doing designing intentionally vulnerable boxes, deploying them, setting up, or I think scoring actually handles Koth, but you'll help with scoring those Koth boxes. A bunch of fun, really interesting, and unlike pretty much anything you do normally. Next, the networking team. This is a 50-50 chance for most competitions, whether you need it, and the reason for that is sometimes we need physical networking. When we run Raspberry Pis or something custom, like I think 2 ISTSs ago, we had IP cameras that ran over, and we were able to red team would hack into them, and they could see exactly what we're doing, stuff like that. During like a scored service, they'd be in charge of making sure that those can actually reach our stack. So this sometimes get lumps into infra, but depending on how complex the networking is, it can be its own independent team. Last is the CTF team. So in speaking of that like competition within a competition, stuff like ISTS runs its own CTF. So they're in charge of designing challenges. I know that a lot of people here were at the Eaton CTF, running something very similar to that, because again, it's not the main focus, but we want to make sure that we're spreading within the people who are running it are not spreading within the competitors, so that it is hard. So maybe not the hardest challenges, but it makes it a ton of fun. So yeah, makes challenges as well as all the background info to it. Oh, this is me too. So I think one of the things that coming in, and I don't know how to explain this, but forever everyone thinks Terraform is like one of the hardest things in the world. It's not.
who in the room knows Terraform?
Yeah, who knows Terraform?
Who or knows what it is at least? It's okay. Don't raise your hand if you don't 100% know. It's okay. I don't know if they got. I'm pretty sure they're always been under HashiCorp.
I mean, they went close to it or something.
It's still 100% open source.
They don't license change. Yeah. That's
Yeah.
what I was thinking.
Yeah, license change. Yeah.
Yeah.
All right. So there's like 2 people, right? This is one of the big services that we use. Max is going to explain a little bit about it, but you're going to hear these things throughout your time here at RIT, and for anyone online who's not at RIT, you're going to hear these things throughout your career. All these different technologies. So don't be afraid of them just because you don't know what they are. That's what presentations like this exist for. These next 2 sections are probably going to be a bit technical, and if you don't have pre-existing like programming knowledge or anything else, don't be discouraged. I promise you will get there. This presentation is designed to target all skill ranges. So we're giving a little bit for the non-technical folks or the not as experienced folks, and we're giving a little bit for the experienced folks as well. So please do not take this as like, oh, that looks way too hard. I can't do that. You will get there. I promise. Nod your heads. I need audience participation. I need validation right now, okay?
Yeah, so as we saw, there's a lot of people that either don't believe they know it or don't understand it. I promise you, Terraform is probably one of the easiest things that you can learn. So with Terraform, let's get started with it. It is an open source infrastructure as code tool built by HashiCorp. So what's infrastructure as code? It's being able to represent the physical or like an actual state of your infrastructure via code. Kind of goes back on itself. But let's say that you're a big company and you want to deploy 2,000 of some kind of server, and you have the Terraform to represent that. So it is pretty much a one-to-one mapping to understand, hey, I have this infrastructure, and then I have the code describing it. If you want to change one of those servers, 1,000 of those servers, whatever it is, and you change that in configuration and apply that configuration, you then have access to change all of that. And then your code, what you can have automatically, I wouldn't say documented, but you have something that you can refer to describe everything that you have. So that's the idea of infrastructure as code, and a lot of DevSecOps is moving towards that, because otherwise it's a guessing game. You don't know who's controlling what, and stuff like Terraform provides you a single source of truth for knowing what kind of infrastructure and resources you have. So, and then you can also automate it pretty well. So Terraform, you build, deploy, and destroy resources. It's going to be depending on exactly what you're doing with Terraform. The other thing to know about Terraform, it's extremely flexible and extendable. So we'll talk about a couple things that you can do with Terraform, but there's providers for you to order Domino's pizza. Like quite legitimately, you can have a provider that orders you a pizza and it will get delivered. So you're thinking that and you're like, this is the same thing that deploys VMs. Yes, because another big thing to know about Terraform, it's a configuration language. HCL, HashiCorp configuration language, it itself is Terraform, or Terraform is an abstraction of that configuration language. Pretty much all you're going to be doing is describing resources and then running those resources, building them, deploying them, and finally destroying them. It goes through this life cycle, and you're able to define your own providers and build pretty much anything you want to build with it. So this flexible configuration files, HCL, I will say that unless you've seen HCL, it can be a little bit confusing to understand when you first see it. Think about it on like the same level as like you see like XML or HTML or Markdown, YAML, JSON. It's doing exactly the same thing. It is providing structure to unstructured data, and you're able to understand that. So next, providers are one of the biggest things that you're going to have to understand with Terraform. I say that you can understand Terraform easily within a day. To understand a provider, it might take more time. Terraform itself is the underlying system which you can connect to multiple providers, so that Terraform can connect to the AWS provider to deploy you a system. But you can connect to and then you can connect, let's say Cloudflare DNS provider, and set up a DNS, DNS for that exact thing. So you can have all that configuration. You can have several providers, and it will be a little bit to learn all those providers and how to use them. But Terraform itself is something that you can easily grasp onto. So yeah, we see like GCP, AWS, Linode, OpenStack. So realistically, this abstraction that is Terraform, you can easily switch to any of those very quickly. Lastly, we talked a little bit about stateful configuration, and it does exactly that. Whenever you're applying, which is running Terraform and making sure that state matches what you want, that creates what's called a state file. State file will pretty much describe your entire infrastructure so that you can start to gather facts about it and just use all the information about that. And then you use your state file to eventually destroy the infrastructure, change the infrastructure, whatever it be. So let's go through the entirety of the Terraform language. There is eight directives. 1, 2, 3, 4, 5, 6, 7, maybe 9. I can't count. So first is the Terraform directive. This describes all metadata. At the top, we see that we're just defining a new provider. This one, we're just going to be using the Linode provider. Simple as that. Provider, we're just recalling that and supplying the provider with anything it needs. In order to deploy something on Linode, what are you going to need? Well, for here, we're providing in our API key so they can perform anything that we need. There's two kinds of main variables that you'll be using. One is called variable. The other is called local. You can think of local as like static variables. You're like, oh, what's the long name for a machine that has like 2 CPUs and 8 gigabytes of RAM? Well, you could just rename it to anything you want and then just reuse that. Variable. This is something that you can actually overwrite or plug into, whichever you want to call it, using just environment variables. So instead of statically putting in your API token to your Terraform, you can just read it from an environment variable or other things. Next, resources. This is one of the biggest things. This is the actual object. So when you have a DNS record, that's a resource. When you have a virtual machine, that's a resource. When you have a network, that's a resource. These are the code snippets that actually begin to deploy resources and get represented as infrastructure as code. Last three, you may use, you may not. 2 of them I've personally never used. First is output. So you deploy a VM. How do you know what IP it has? Well, you output the IP, and then at the end it says you made this system with this IP. Data. This is a way of grouping or querying resources. So theoretically, you can use data to represent like all your Ubuntu machines, just using something like this, where we're looking at all Linode images with Ubuntu, and then we're naming it Ubuntu, and then we're just searching for ID is equal to Ubuntu. And then lastly, modules. It's able to just define, and it's meant to define and reuse common objects. What that means is you have something that's going to be reused 1,500 times. Everything gets deployed on the same exact network. Create a module for it, and then you're able to reuse that a ton of times. You guys know Terraform now. It sounds super complex. Sit down, write a little bit, and you're going to be able to deploy stuff very simply. And I'm actually going to show you that right now. So let's start with our first example. The goal here is we're going to be deploying a single VM on Linode. Okay, so what are the prerequisites here? So first, our provider. Provider is what we're actually going to be interacting with to deploy Linode, a system on Linode. We declare the new provider just using like versioning, and that's pretty much a Git source. We also initiate the provider using provider Linode, and then we provide a API token to it so they can use that for everything. Super cool. Next, we declare some variables. On the back end, from what I'm going to be showing you is I'm going to be sourcing some environment variables so that you can just plug and play and not have to deal with type in your API key every single time. Now, the actual meat and potatoes. Let's deploy a resource. So resource, Linode instance is defined by Linode itself. It's going to say, yeah, you're creating an instance, you're creating a VM. And we're going to name that, not name the instance, but the reference to that Terraform example. The rest is all custom to Linode itself. We're saying that the label is Black Team example. This is the name, type, this is the G6 Linode 1. How I was saying, like, oh, do you really want to remember that? Or do you want to say, like, smallest resource that you can have? We define a region, image, we can put SSH keys in, and we can add a root password to it. And we now have a machine. Let's look at what that actually looks like. I'm just realizing that I'm not going to be able to hold this.
Does anyone have any questions before we do the demo?
Yeah, no.
Anything. It's a very technical topic. It's kind of difficult.
It's
one of the things that we didn't demonstrate here is that a lot of times when you're not using Linode, for example, I know OpenStack. One thing that Max referenced, that data at the end, that is supposed to represent things that don't exist in your Terraform. You're pulling data from the cloud provider that already exists out there. Let's say you went in AWS and by hand, like you went in the AWS console and you made a network, right, for your entire business, right? This is your business network. You didn't use Terraform to make that. So now you need to use Terraform to query for that because it already exists. So there's a very good distinction there where data is things that already exist before you run it. Resource is things that Terraform is going to create. All right, now I'm going to hold this for Max while he runs this demo. And if you have questions, stop us in the middle. Oh, question. Well, yeah, that's a really fantastic question and something that we use for our competitions. Other businesses will use. A lot of times when you're writing Terraform, you're working with an environment that was not originally Terraform. A lot of times when you go work for X company, their network is already going to be defined. They're going to have to like manually create things for you. Maybe you want to automate your team's piece of it, but in reality, if your company is not already using Terraform, and even then, they're probably not going to give you access to their Terraform, right? So even if they do use Terraform to deploy their infrastructure and configure all their enterprise policies, they're not going to give you that Terraform. You're going to have to write your own Terraform that references the stuff that their Terraform deployed, right? So this makes it so that you can kind of do like a quick search on AWS for these kinds of things. A data will, the way it works in the backend, and I promise I have pored over the Terraform source code. That's the only reason I know it's still open source. But I have looked through the Terraform source code. It is Golang, so if you know Golang, you can look at the Terraform source code. Data takes all of the same inputs, attributes as resource. So similarly to this resource here, this Linode instance resource, if I wanted to look up an instance that already existed and I wanted to create a new network and connect that instance, let's say you have an AD server that's already deployed by your enterprise IT. Okay, you want to connect that AD server to your private network. So now you're not going to redeploy the AD server that's already made. So instead, you'll change this tag from resource to data. So instead of creating it, we're going to look it up now. Same kind of idea. You have to tell Terraform what this is that you're looking up, and then you give it a name that you can reference it by. Same idea as resource, except now, instead of setting these things, it's going to perform a search based on these attributes and try and find the thing that's closest to matching all of these. So it will go through. It will list all of the instances in your Linode project. And then it will search. It will say, oh, this instance matches this type, but it doesn't have this region. This instance matches this type and region, but it's the wrong image. And so we'll find whichever one has the highest attribute count, whichever one matches most of your search parameters, and use that. And then you can now reference that pre-existing thing in your project. So for our example, the AD server, you have a resource, which is a network, your private network that you want to connect to Active Directory. And then you would use the data to then get a reference to that instance and a final resource to attach it. Does that make sense? Yeah. So it's like performing the Google search. I use Google as a verb because apparently it's a verb now. It has been for a while. But yeah, you're basically just searching for all of the data instead of creating it. Are there any other questions about that? All right. Well, there is that chance. So if it can't find something that's referenced by your data, your Terraform will fail. And Jason, I don't know if you know, does it actually perform the data queries before you apply? I think it does, right?
Yeah.
When you do the Terraform plan, it'll search all the data queries. Yeah. So something that we described we kind of skipped over a little bit because it gets a little too into the weeds. But to answer your question, there are multiple steps to building infrastructure with Terraform, and you'll see those when Max goes over it. There's something called the Terraform apply. But before that, you have to do a Terraform plan. And so this kind of does like a dry run of your stuff to make sure that what you wrote is going to work. And during that step, it'll actually do all the data queries, and it will fail if it can't find something before you actually try and run it. Does that answer your question? Any more? All right.
Let's see if this microphone works. Testing. Oh, cool. That works.
Well, it doesn't work for the room, but that's okay.
No.
It's because it's using that microphone.
Testing. Testing. It's okay. It is what it is.
Just speak loudly.
Oh my god.
Can everyone hear Max if you just talk really loud?
Cool. Okay, guys. We see this, and we're actually going to do exactly what we're doing. We're going to be running this Terraform, seeing how it works, and here we go. So first thing we're in this little Terraform directory. Yeah. Oh, I'll also increase some like sizing. Just move it into the. Just move it as a tab. Just click on it. Move into editor. Oh, I've never actually used that. Let's go.
Okay, we're teaching Max things.
Yeah,
right now.
I didn't know VS Code had that. Okay, we have all the same information. What I've done is Terraform. You can theoretically put every single piece of your Terraform into a single file, and it works. Or what you could do, which is way smarter, is you break it up into files. So I have 3 files. I have my main, which is what is actually going to be running. I have my provider, which lists my provider. And then I have my variables, which lists my variables. Pretty simple there. So it will automatically interpret, look at all your TF files, and it'll just run it when it figures it out. So let's start. Oh, and also for those of you curious how environment variables work with Terraform, if you export a variable just as uppercase TF_var underscore whatever your variable is, it will automatically interpret that as a Terraform variable. And you just have everything locked in. So first thing we're going to do, make sure that our environment variables are actually there. We're going to source our little env file, which has all our API keys, SSH keys, stuff like that. Another thing is the first step of anything Terraform is Terraform init. This will make sure that your project's ready, has all the stateful files, make sure that it actually understands everything. Or not understands everything, but that stuff exists. Cool. We've done TF init. Next, as Brad talked about, we have TF plan. Plan will go through all your Terraform. It won't actually check and go against the provider and say, oh, well, I can't actually deploy this instance. That happens at runtime. But we get a plan of everything that's going to happen. So Terraform will provide the following actions. And it gives you resources, tells you what keys it's going to add, type, stuff that you won't know until after, after it's been deployed, are just like known after apply, has my password, which it lists as a sensitive value, our image, we can see all that. So what's left to do? Terraform apply. We're applying our configuration. Let's say yes. We're saying we can run all that. And let's actually look at Linode. Let's see this happen as it's going. If I could spell Linode. Okay, we'll log in. Okay, now we're at Linode. Well, right there, Black Team example, provisioning. Tell me TF apply. Everything that we just did is waiting, but we've deployed an instance. Terraform, you can easily expand, make a second instance, and once this does apply, we're going to do a little update of stuff. We're going to say, let's change the name of it, and let's hope that it actually doesn't take too much longer. But yeah.
You can take it and make it changes.
You can make changes now? Yep.
Yeah.
And we even get our output, which is our instance IP. So let's go back to our main TF, and let's just name it. Yeah, let's. VS Code wants me to name it example Terraform. Very cool VS Code. And I forgot I have the little SSH thing here. Let's TF plan. Make sure that we didn't make any mistakes. And right there, pulls from our state. It says, "Oh, you're changing Black Team example to Black Team example Terraform," and we're hitting this ID, which is my box. Okay, cool. Let's apply it. Wait a little second. Let it figure out. Modifying value. Right there. Terraform example Terraform. Very cool.
Something to notice is that it didn't actually delete the VM.
Yes.
So certain things, certain attributes will trigger the VM to remake. Like if you change it from Ubuntu to Windows, it's definitely going to have to delete it to remake it. But it will list in the provider documentation what things will actually trigger a redeployment of the resource. But you notice that it is modifying one value without redeploying the entire thing. So you're going to have to refer to your provider documentation to figure out what exactly those are.
Yep. And just as simply, we can redo it. Now let's talk about the last thing, which is sometimes a huge pain. How do we take these resources down? We just deployed, let's say, 1,000, 100,000 VMs, whatever it is. Well, we have this nifty little command, if I can spell it right, tf destroy, terraform destroy. It says, hey, are you sure you want to destroy all this stuff? And there's more in there just because when you create a VM in Linode, it's like, oh, we're also creating you like backups and this and that and this. And so when we destroy, it's going to be a little bit more. There's a little bit more that gets described. But exactly like that. Let's see. Can we see this getting destroyed? Yeah, it's already destroyed. It's saying it takes a second just because there's some stuff on the back end that it's probably doing. But it's destroyed. We have created Terraform. We've planned it, made sure that it would work. We've applied it, updated again, and destroyed it. And I think this demo took 2 minutes. Probably more than that. But extremely quick, extremely efficient. Let's talk about something that most of you are probably thinking, wow, Terraform. You can do VMs. That's like its main purpose. Like that's what everyone uses it for. What if we deploy Discord server? Like I was saying before, Terraform is built for anything. You can order a pizza, you can set DNS records, you can make a Discord server. So here we see our like baseline, our Discord provider, our Discord token we're keeping as a variable, and what are it's a little bit cut off by the captions, but our main are like all our resources. We're creating a Discord server called TF_server. Next, we're making it have a general channel. A general category. We're putting a general channel in it. And then lastly, we're looking up, we're creating an invite for the general channel. And then lastly, we're printing out the invite. Super cool. Let's actually get started and doing this. I think
We might have to skip the demo.
It's
okay.
Yeah.
You can just run the apply and then we'll destroy it later.
Yeah, I think it's already.
We're just gonna skip straight to the apply here. It'll generate a plan.
Yeah.
We're just gonna quick speed run this because we are running over time.
Oh, you know what? I think I actually forgot to destroy it. So let's see that it works. Yeah, Terraform server.
Oh wow! It
Oh my
ran.
God, that's the
That's
quickest Terraform ever. You have a little general server. Yay!
Literally the fastest Terraform you've ever seen in an instant.
Oh yeah. Well, let's destroy it just so that we can show that we can do that. Source env, get our stuff back. Oh, we can actually tf apply and it'll say that. Oh, that already exists. Oh my God, why can't I? Yeah.
TF. This is what happens on Max Stress.
Yeah. Oh my God, it deployed.
Oh, that's crazy! It deployed. Wow.
NTF. The story.
Yeah, it's okay.
Yeah. Okay, and it's destroying. We say yes.
Gone. Wiped out of
Boom.
existence.
Wiped. It's fucking Thanos snapped. And it's gone.
Wow.
Yay.
Everyone clap for the people. Yay. Okay. So now the story is you have some funny little VMs, right? Well, now it's a pain to go actually like set up things on there. I know we have entire classes based on like setting up things on VMs, but did you know that your funny little thinking rock sitting right in front of you, the thing we call a computer, can just do that for you? Our computers configuring computers. Who would have thought? This is the future. Okay. So there's this technology called Ansible. Ansible, it's all Python. So for you Python people, you're gonna get off on Ansible. Okay. Ansible is wonderful. It's a tool for automating all kinds of workflows. There can be way more than just doing your typical sysadmin work. There are a ton of different Ansible modules. So just like Terraform has providers, Ansible has modules to do different things. There are tons of different ones. There are community ones. There's probably Ansible to order you pizza at this point. I don't know that it exists, but it probably does. There's probably also Ansible for Discord. I feel like that's definitely a thing that exists. But for example, let's say I have a Ubuntu VM that I just deployed with my fancy Terraform, And now I want to add some users to it with some keys. I also want to set up Apache with WordPress, and of course I need a database to connect to WordPress. So a lot of that is, a lot of work. My favorite thing is to just go hop on DigitalOcean.com, find that little DigitalOcean guide on deploying WordPress. If you check my search history, it's probably in there a billion times every time I have to deploy WordPress. If you didn't know, DigitalOcean has wonderful sysadmin guides. But if you don't want to do that, you can just use Ansible. You can do it. You can create it once, and then you don't have to be like me, where I have to look it up every single time. All right. The idea is to create like a Lego-like configuration. It's all based on a language called YAML. This is the thing that you write your Docker Compose files in. So the idea is that we have a bunch of different types, and they all plug into each other. Like roles have tasks, and playbooks have roles. We'll explain exactly what those are. But it's this massive tree-like configuration that eventually helps you configure your VM in an executed order. So first thing you got to know about is what is the Ansible inventory. So the inventory is going to be what you get as an output of your Terraform. So just like we outputted all the IP addresses of the boxes that we deployed, even though I know it's only one, imagine you're doing this with 100 and you set up 100 identical web servers to load balance. It's a lot of work to do by hand. So all you do is output all of your IP addresses from your Terraform, plug them into your Ansible inventory, and this stores references to all of the hosts that you want to log into. On the back end, Ansible is going to use either SSH, WinRM, PowerShell remoting, depending on Windows, Linux. There's a lot of different ways the Ansible can connect to the box, but the idea is that when you have Terraform set up, you have remote access to it. Now you can plug it into Ansible. It's going to store references to all these hosts and how to log into them. You can group these hosts, so if you have multiple different types of resources you're trying to deploy, web servers, Active Directory, etc., you can group them so that way they all get applied together. And you can also apply variables to hosts and groups, so you can apply specific configuration variables to individual groups and not just to everyone as a whole. This is an example of what they look like. So there's two different types. I said YAML before, but technically for an inventory, you also have something called an INI file you can use. I think if you're a Rust user, I think they use INI for cargo files, right? TOML. It's kind of like INI configuration like TOML. I don't know if someone's going to come at me for that, but I think they're similar. That's all that matters. So INI file, I used to use INI files all the time, but I'm kind of a YAML lover lately, so pick with what you will. Some of these are comments just to demonstrate. You've never used YAML or INI. INI uses the semicolon as a comment, which is, I know it's weird to see it at the beginning and not the end, especially if you're like a Java person. But YAML uses hashtags similar to Python. It's really nice. But these are groups. Just like you can see, these both represent the same thing. I have all of my hosts here, and then I can group them into, I group the two web machines into web servers, and then I say that both of these are Linux. I also have another one that's commented out that's a database. Yeah. So Ansible tasks. These are something that carries out like a single action. So think of download a file. Okay? Anything that you would do on a machine, that's a single action, and Ansible task can do. So if you can SSH into a VM and you can run wget URL, that's downloading a file, that's a single task. So it has to be one single unit. These use what are called Ansible modules, like I referenced earlier. So maybe this uses the Discord channel module and creates a Discord channel, or maybe this uses the pizza module and orders you a pizza. I don't know. But for example, like Ansible the built-in package, this will use whatever package manager is local to the host. The nice thing about Ansible modules is, especially the Ansible built-in ones, they are what we call OS agnostic. Does anyone know what OS agnostic means? Raise your hand, any brave souls, what's up? So yes, runs on all operating systems, even Temple OS. Yeah, maybe. Your mileage may vary. But yeah, so the idea is to be OS agnostic means that no matter what, you can use the same exact configuration here, and it will run on Windows, it'll run on Linux. I don't know if that runs on Windows, but many different Linux distributions have different package managers. It'll operate across all operating systems equally. These can use variables from the context, like I referenced earlier. You can set variables on groups, you can set variables for everything. this is a nice way to include things like Max use, like for API keys. Maybe you want to have one reference to a name that you use everywhere, that kind of stuff. These tasks can also be run conditionally or in loops, like we'll see here in just a second. So for example, this one is going to create admin users on a machine. I'm actually running this in a loop with something called with items. And I promise this is may look confusing at first, but all of this structure in YAML is documented on the Ansible website. They have fantastic documentation. I really applaud them. Stick to the end to see my presentation on documentation. Shameless plug / segue. Okay, so Ansible built-in user. This is going to create us some users. I'm iterating over a list that I defined somewhere else in my variable files. So I define a list of users. I'm going to go through each of those users is actually YAML object. Like I said, for the documentation, but we're setting the username and password. We're saying they're all part of the sudo group. They all run in bash. Create them a home directory, please. And then this is nice because we can use one massive users list, and if we don't set the admin variable on it, it won't actually run in this loop. So we can use conditionals within a loop to apply stuff to a module. This is kind of everything in one. I promise you're not going to use all of these options every single time. This is just the most complicated example I could create off the top of my head. So Ansible roles are going to group these tasks into a larger thing, right? Because tasks can only accomplish one thing. Download a file, install this, do that. But Ansible roles, let's say we want to install Nginx. That requires downloading some GPG keys, adding a repo, and installing a package, writing some HTML to this directory, that kind of stuff. So there's going to be a lot of tasks within a single role, and a role should accomplish one, I guess, larger action is the way we're going to say it. So that would be install Nginx, install WordPress, install MariaDB. You can have separate install and configure roles if you want. It's really up to you. It's super flexible. But these roles can actually contain defaults for variables. So let's say I don't want to specify a variable. It'll actually fall back to this default that I've defined. You can also have template files. So let's say on every web server, I want it to contain the host name in the actual HTML of the website. I can template that, and Ansible will fill out that data for me. You can also have handlers for repeated tasks. Let's say every time you update HTML, you need to restart Apache, or every time you update the Apache configuration, you need to restart Apache. You do that 50 times. Instead of creating rewriting that same task to restart Apache every time, you can create a handler, call to it. I'm kind of speedrunning this just because we're running low on time, but if you do have questions, remember, raise your hand, please. I will answer any questions. This is the file directory structure of what a role looks like. This is something what you call like Ansible Galaxy format, I think. So Ansible Galaxy is like all the community modules, and if you want to publish your module, you have to write, or you publish your playbook, you got to write it in Ansible Galaxy format. So in your roles folder, you can have some role name like install Nginx. I like to use underscores in my name. There's like a big debate like a few years ago on our black team, like hyphens or underscores, and sometimes it was mixed and it was annoying. So I think we're all underscores now. Is that right? Yeah. We're team underscores. All right, team underscores. Okay, I don't want to see any hyphens out there. Okay, so you're gonna have a folder with tasks. Anything you see here named main.yaml, Ansible's only gonna automatically include that. But anything that you don't name main.yaml, you're going to have to explicitly include that. Refer to the documentation on how to do that. But typically, you can just leave with main.yaml. There's the tasks that I talked about. They live in there. Handlers live in there. These are the templates. They use something called Jinja templating. You can also look that up. That's a Python thing. They typically try and leave them as J2 so people know that that's a template file, not just a regular file. The files directory is for those regular files that are not template files, you just want to copy over to a machine. Variables that are associated with this role, as well as the defaults for those variables. Typically, defaults, they have lower priority. They can be overridden by variables. But typically, anything in the vars folder, I think the standards in the vars folder, you're really not going to change it that much. Defaults are for default actions that you override at the playbook level. We'll get to that. This meta is when you publish your role. You gotta add in some metadata. There's a few other folders here for published modules. But this is kind of the example here, like Linux deploy Nginx. So I know that, this is a part of like naming your stuff sanely. Also another shameless plug in my presentation later. This is another thing about like naming your things, something you can understand. Just from looking at the folder name, we know that this runs on Linux and we know that it deploys Nginx. That's all we need to know, right? Same thing with Linux create users. We know it runs on Linux and we know it's creating users. That's all we need to know. Self-describing names. So a playbook, this is what you're going to actually run, okay? This is the massive thing, i.e. deploy ISTS, deploy IRSEC, all right? This is the big cheese, as Anthony would say, okay? You're going to group all of your roles into a massive deployment, and you're going to say which hosts each of those roles runs on. So let's say you're going to use, you're actually going to use some logic to figure out from your host file. Earlier we can see that we have two groups here. We have Linux that lists all the boxes that have Linux on them, and we have web server that lists all the boxes that need a web server on them. These may not be like, they may intersect, they may not in the real world. This is just an example. Okay, here we go. So we can use logic to select hosts from them. So let's say we want to get only the machines that are both Linux and they have a web server, right? Because remember, we had a Linux install Nginx. So we know that it needs to be Linux and it needs to be a web server because it's running Nginx. If you don't know what Nginx is, it's basically just a server. Sorry, I didn't actually clarify that. Yeah, so we can use this ampersand to actually say that, hey, we only want the boxes that are both Linux and web servers. Maybe we want all our boxes are web servers and we're being loosey with our logic. We can say we can get Linux or web servers. So this will actually deploy on every Linux box or if it's a web server. And this will actually deploy on all the Linux boxes that are not web servers. So do with that what you will. We can use logic to select these hosts and then choose the roles that run on them. So this is an example playbook. Here we go. We're going to create users on every box. So we use a special keyword all. All is always represents all of the hosts in your inventory. We're going to create the users on all of our boxes. We are going to install the web server only on the web server first. So this is an example of how you can select which roles will run on which hosts. Like I referenced earlier, Ansible variables can live in many different places. In the inventory file, you can define these per host. I did define them earlier. Here, you can actually see that there are some variables here, such as Ansible_host. This tells us what the IP address of the host is. That's considered a variable. So you can define them in your inventory file next to your host. There's something called the group bars folder. This, you'll create a folder. Oh, no. You'll create a folder named group bars. You create a file in that folder with the name of the group you want the variables to apply to. So I can create an all.yaml that will apply to everything. I can create a web servers.yaml that will apply only to web servers. And then I can apply specific variables at that level. Let's say all my Linux machines use one user, all my Windows use a different user. I would use a Linux.yaml to set the user and password, and a Windows.yaml to set the user and password. You can also define them in your playbook directly next to where you're specifying the role. There's also a bunch of Ansible magic variables that get populated when it does something called gathering facts, like the host name of the machine, the IP address, all this kind of information about the host that you're running on. I included a link here. There's way too many to describe. But this is an example.
Oh, this is part of the demo.
Oh yeah, this is part of the demo. I'm going to hand it over to Max to show off this Ansible demo. I'm going to try and go as fast as we can. Is there anything after this?
No.
Okay, I meant in our slides. Sorry. Yeah, no, I think we're running to the end, but thank you for staying with us over time. Oh, wait.
Yeah, I'm going to switch off the microphone. I forgot. Also, the thing I forgot is I did not mean to stop the server from before. So quickly, using the power of Terraform, we're going to quickly put that back up. So tf apply. Oh, wow, we have a new server. Okay, while that's creating, let's talk about our playbook. I want to do something super simple.
See if anyone can guess what it does.
Guess what this does, not like the name is exactly what that is.
Raise your hand. Who wants to answer?
We need some.
Well, you already answered one. Let's see if we can get someone else.
Let's see.
Oh, God, Joe.
No, wrong.
Wow, that's crazy. Kyle said it enables Apache.
That's one of the things.
I promise it's not a trick question.
Yeah.
It's just to see if you were paying attention. Oh, Reina said it installs a web server, maybe. Drew agrees. And enables it at boot. Okay. All right. Max, take it away.
Super simple. Yeah. Our playbook here, we're just naming it install Apache web server. What does it do? It installs Apache web server. You see that it's going to be run against all hosts. Become true just means if you're not root, become root. Or whatever your defined root user is based on your
Elevate privileges.
Like
on Windows, run as admin.
Mm-hmm. So what are the tasks we're defining? Because you can define roles in playbooks, but let's get a little bit simpler. Let's talk about tasks. Because you can just define tasks within a playbook. And for here, we're going to update the app cache. This is just completely stolen from ChatGPT because it's amazing at stuff like this. But we're updating the cache. We're installing the package Apache 2. And then finally, using, they have built-in system. Yeah. Ansible has built-in packages. We're using systemd to not only start Apache 2, but enable it. And something that I want you guys to all notice, it says started. When we're dealing with Terraform and Ansible, they're stateful. They're idempotent. Idempotency is a huge thing between these two. It's a big word. What it means is it knows what it wants. It says, if, yeah, you know what you want, stuff like that. But it knows what it wants. When you say, move this file, Ansible's going to say, is it already there? And it's going to like figure that out and then say, actually, I won't install it because it's already there. So it knows.
The idea is if you run it multiple times, this is like the general definition. If you're going to run it multiple times, it will give you the same output every time, even if you run it twice in a row. It won't change it the second time because it's already done it. So the idea is that both Terraform and Ansible already know what they've done on a host. And it will check to make sure that those things are done before it actually touches anything. Because if you did something by hand, it doesn't want to mess it up. That's the idea.
Exactly. Okay. So we see this. We understand it. It's pretty simple steps going there. We now have our input, which is going to be this little IP that we have. I didn't disable root key checking, which is like a small thing, which will basically say, oh, have you ever looked at this host before? So let's make sure that we can actually connect. We get our little 1Password pop up, and we have access. Cool. Now let's move to Ansible, where we're going to be doing, guess what, the Ansible demo. So we talked about before this command, yeah, Ansible. Ansible playbook. So what does it do? It runs an Ansible playbook. Let's do a couple things with that. So first off, let's open our Ansible folder. We can see this playbook.yaml, which was exactly what we saw. We're going to say we're going to be running this playbook. Okay, next question is going to ask on what hosts. And we can actually just provide it an IP. And the last thing, because I didn't set up group vars, because Ansible is extremely flexible and you can use it for a ton of things. And here we're just going to be manually doing it so that this code can be reused. We're going to define a user. And because we're on Linode, the default user is root. And let's run it. Oh no.
The idea is to not do what Max is doing if you're trying to make something that you're going to come back to in the future, okay?
Yeah.
This is like a one-off thing. Follow the best practices, go back through the presentation, read the documentation, they explain it all.
Yeah, I made a little mistake. When you're declaring inventories where it's just a list of IP addresses, and you add a comma at the end to say, hey, this is a list of IP addresses and not a file name. So let's see what it's doing. So gathered facts, this is basically all those like special little variables that Ansible knows what it's deploying on. It updated cache, it installed Apache 2, and it started it. So we can see here that from installing Apache 2, that already starts and enables Apache 2 at boot. And Ansible knows that because it gathered the facts. And it says, it gathers facts before it as well as all the way at the top. But it knows that it already runs, it already is there, so it doesn't change anything. It's already okay. The state is there and it's working. we can see we had those two changed. And let's see if everything's working. We've never touched this box before. We've done no configuration. We never went into the Linode manager and checked it out. And we have Apache running.
It's okay, you can find
Yay! Oh,
So take note of everything that was yellow there before.
yeah.
Okay, it's updating the apt cache, it's installing Apache, right? So now we're going to demonstrate the item potency, okay? You can see one thing that we never want to just assume is already done is updating caches, because if we're updating cache, we're doing it intentionally. But now that you notice, it's not reinstalling Apache, because Apache's already there, right? We've already run this. So the idea is you can run this same playbook as many times as you like. And if we go back, it's the same exact output. The web server is still going to be up the exact same way.
Yeah. Another really cool thing for Ansible that, honestly, a previous job showed me this, but our entire configuration for our laptops was an Ansible playbook. So you, instead of going through and installing all the apps you needed and getting the correct permissions and getting like secrets involved and this and that, and it probably like would be a 3 or 4 day process to go through all our onboarding. You get an Ansible playbook that you could run. And if at any point that you needed to just stop and do something else, Control C, you go out of the playbook, and it will know what it's done just based on Ansible knowing item potency. So all your install was an Ansible playbook that you ran on your own machine.
There's a great, and this is actually a pretty common thing. For those of you out there that like run Linux on your machine and you know that sometimes you install like a goofy little kernel module and then you go to restart and it just like doesn't turn back on. Yeah, for that exact situation, Mr. Chase K knows, that exact situation, like when you're running like Linux and these self-managed operating systems, you can mess things up a lot. So if you just have Ansible that deploys and configures your laptop, all you need to do is wipe it, reinstall the operating system, go pull your Ansible from GitHub, and then rerun it on your machine. There's very little like manual configuration that you need to do to get back to where you were. So that's actually a really common thing, storing all your configurations and all of your like installed. You create Ansible, you store your configurations, like all your dot files and that kind of stuff, from your home directory in GitHub. And then you also write Ansible to reset up your laptop exactly the way you have it. You can keep this updated all the time. Maybe you don't use something anymore. Maybe you have some additional software you want to get. It takes some time, but if you're used to refreshing your laptop very often, which is honestly probably a good thing, more of us need to start doing that, having Ansible to deploy your laptop is fantastic.
Yeah.
Does anyone have any questions about Ansible or the entire presentation as a whole? I know we kind of rushed through at the end there, but we're like 30 minutes over time. I'm sorry. It's a very dense presentation. Who's interested in black teaming now? Okay, wait. Lower your hands if you've already been on black team. Sorry. Who's interested in black team who wasn't on black team before? Wow. Okay, good. I see a lot of hands. That's good. All right. But yeah, now you got a little bit of insight into black teaming. Super cool. Now you know why it's cool. You should come do these things. Just like we said at the beginning, if you are interested and you don't feel like you have enough technical skills or you just want to kind of observe, there are those non-technical roles such as like doing injects and scoring, even white teaming during the competition. That gets you insight into all of that. You can come observe, ask questions, learn. Honestly, most of the learning that I've done to get to this point is literally just sitting in the room with smart people. I promise you that's all I did. My freshman year, I would come in here, we'd go in the labs upstairs they would be building the competitions. I'd sit in the lab, no idea what black teaming was. I could barely blue team myself. And I'd sit in the room and I'd be like, whoa, this is super cool. What are you doing? And then they'd sit there and explain it to me. And I'd be like, okay, I don't understand 90% of what you just said, but I appreciate it. And I ask more questions and learn and just absorb. Be a sponge. That's the kind of goal here. Be a sponge, absorb knowledge. Surround yourself with smart people, or at least people who you think are smart. You're not always smart. I can't promise that. Like me. Don't worry. I don't know Rust. I already said I'm too dumb for Rust. All right. No questions? All right. Demo time. Mr. Alex, come up here.